The ballerina can achieve balance on top of the man's hands because the net torque and the net force are equal to 0, thereby achieving static equilibrium. The system of the man must also be considered. His hand is exerting a normal force upwards to support the woman. It is interesting that he isn't holding the ballerina straight above his head so that his arms are parallel. This would be easier because the net force and net torque would automatically equal 0 with little help from his arms. Because he is holding the woman at an angle, she is exerting a downward force, causing a torque out of the page towards us. This torque must be counterbalanced in order to attain static equilibrium and hold the girl above his head. The muscles along his arm exert an individual force upwards, resulting in a net torque into the page that will counterbalance the torque caused by the ballerina. It is important that the center of gravity is over the surface area that is in contact with the floor, or in this case, the man's hands. Because we are on Earth, where the gravitational force is constant, the center of gravity is located at the center of mass. If the center of gravity is not over the surface area, then she will fall over. This is due to the principle of torque. Dancers are constantly changing their position and therefore constantly changing their center of mass. When an arm or leg deviates from the normal standing position in first position, the center of mass will change. The new center of mass can be calculated by treating each limb like a point mass and then averaging the position of masses. In this case, the center of mass is still around the same point. Point is a difficult skill in ballet. It is harder to balance because there is less surface area at the point of contact with the floor. The center of gravity must pass through the point of contact exactly in order to balance. When you are on point, there is less surface area, and the ballerina must be very accurate in the positioning of her weight. In a larger surface area, one can distribute the center of gravity, so to speak, over a larger area. The man placed the woman's toes directly over his bones so that it is easier to support her. The bone is stronger and therefore he does not need to exert any additional force by his muscles. One can imagine that there is some degree of pain on the man because the entire weight of the woman is distributed between her two legs onto his shoulders. Because there is less surface area, the man feels a lot of pressure concentrated onto one point. The force the woman applies to create a torque is pushing downwards through her foot into the man's arm in the Y direction. In order to stay balanced, she must have the perfect amount of momentum. Her momentum cannot be that great because she's not turning that much. As you can see, she also stopped by herself, meaning the momentum was not that great because she came to a stop by herself instead of any external net forces being applied. The perfect amount of angular momentum can be achieved by not applying that much force, reducing the radius, or reducing the mass, which really wouldn't apply in this case because her mass is constant. Her moment of inertia changes as she is in arabesque because she is more spread out. She therefore has a greater moment of inertia. This can work to her advantage because this will reduce the amount of momentum she has and the amount of torque she has. This helps her keep her balance and stop naturally by herself. If there's too much momentum, it's harder for her to stay on her rotational axis, and therefore she might fall. She only does things in a short period of time so that she will not fall. As we have seen before, her center of mass changes because the distribution of her mass changes along her body. So therefore the center of gravity must be aligned with the contact she has with her foot and the guy's arm. She does this by shifting her body forwards. The hard part is staying on top of her rotational axis while spinning, while also being on his arm. If her center of gravity deviates, she will topple over due to the torque exerted by gravity and her mass. Friction is a force in the x direction, and it is crossed in the z direction, so she will therefore fall over in the y direction due to friction. More specifically, the torque and the rotation is in the y direction, thereby causing her to fall over. Friction works against the dancer in this situation, and she therefore has to be careful. The friction is reduced by the satin on her point shoes. As we have seen, she does 2 quarter turns instead of 1 full turn. This allows her to have her spotting be in a shorter distance and very quick, allowing her to have the perfect amount of momentum. She has enough momentum to get her to the first quarter turn and then shifts her head and her shoulders, which gives her enough torque to make the last quarter turn. She can therefore achieve this impossible turn. points in the picture show, her center of mass is completely over her pivot, which is her foot on top of his head. This is the way she's able to balance. She completely balances out the torques so that her center of gravity is right over her pivot. Her leg is on the left, while her torso and head is on the right, and her thighs kind of lean to the left, and so is her arm. This therefore shows how she balances out her torques and forces.
Et voilà!